In this video, we're going to talk about expected value. So I'm going to actually give you guys an opportunity to kind of work ahead of where the class is. So this particular topic isn't covered until the next chapter. But I want you to start seeing it now because this particular section does give students a little bit of a harder time. And I want to make it clear by giving us some extra time to process what expected value is. So let's talk about that, what the definition of expected value. So expected value is it's thought of as the long-term average or the long-term mean. Now, it doesn't have to necessarily be long-term. That's just a good example of the type of expected value. Let me give you an example of where you've probably heard of expected value in like life. So you might have heard at some point that there's a statistic that says that on average, the number of children people want to have is 2.5. This is pretty old statistic, I have to admit. But for those who want children, 2.5. Now, I know you and I are both fully aware that you can't have 2.5 of a child, right? I mean, having half a child means you have like a dead corpse of some sort, okay? So yeah, let's just get morbid about it. But the idea is, it's not that they actually want 2.5 children, is that it's technically right in between half, most people wanting 2 and the other majority wanting 3, that they fall into between those two values for the people who want children. That's an expected value. What we're saying is there are some people whose answers might be 1 child. There's some people who might say 4 children, okay, if they're wanting children. And there could be some who are like 10, right? But there's so few of those people. It's the ones who make up the majority that kind of give us this average of 2.5. So not only is expected value kind of what we see for this type of problem, where we're talking about a lot of people, it could be also long-term if you repeat something over and over again for the long term. Okay, so it's not always just long term. Sometimes it's for large numbers. Large number, or even lots of repetition. Something happening over and over again. Sorry, that the word large looked really terrible. I had to fix it. Okay, so it could be large number and not just long term. All right, let me give a simple example, kind of an intuitive example for expected value. I was just watching Into the Spider-Verse tonight, and one scene has the main character who's taking a true or false quiz. And let's say there's 20 questions on the quiz, and he failed the true and false quiz. And the teacher said to him, if you were just simply guessing the questions, what is the score you would expect to get? And he immediately answered 50%. Okay. What that means on a 20 question test is you'd expect to get 10 questions correct. And the reason is you're expecting about half the questions to be right. Why? Well, if you're taking a guess at each question, you have a 50% chance of being correct if there's only 2 options, if it's only true or false. So this is actually following kind of a basic formula. The formula is taking P of X and timesing it by the number of repetitions. So in this problem, P of X is the chance that we guess correctly, that's 50%. And then timesing it by how many times we do that. Well, we do that 20 times on this particular quiz if you're just guessing. And that comes out to 10. So that's the basic formula for expected value. The more detailed formula that we're going to use is could be more complicated. We could be using it for varying probabilities, which we're going to see in just a second. So we're going to actually sum up. That symbol means sum. We're going to sum up the probabilities times a value we placed on each probability or what we're possibly going to see in the problem. I feel like I'm kind of botching that explanation, but it might be better if I show you by example what I mean. So here, I copied this example in just to make it easier. And you don't need to copy this down. We'll just kind of highlight the basics of this. Here we have, in a game of roulette, a player can place a $5 bet on a number. And let's say they choose the number 17. And roulette is the game with the spinning wheel that you see in like Vegas or casinos. All right. Oh, we have a casino local. I can't remember the name. Chinook wins. All right. So you go to Chinook wins, you'll see a roulette wheel. And there are 38 slots. So if you bet on one number, like the number 17, you have a 1 in 38 chance of winning. Okay. Now, what you'll win is $175. All right. And what they want to know is if you play this game, what is the expected value if you play this game? Okay. So what we have are two basic options. We have that you win or you lose. Okay. When you win $175. Technically, though, because in order to win, you have to spend $5, technically, you're really only winning $170. So I'm going to adjust this amount because technically you need to subtract off the $5 playing that you have to spend to play. So you're going to really win $170. All right, great. Or you just lose your $5. All right. The probability of winning is 1 out of 38. And then the probability of losing is all the other possible slots, which there would be 37 out of 38. So these would be my X values, and these would be my probabilities. Now, I do want to say, because I'm losing $5, I actually want to make that a negative value. So 170 is what would be 1, $5 is what I would lose. So according to the formula, what I'm going to do is I'm going to multiply these two. I wrote it in reverse order. I wrote the X first and then the P of X second. And then I'm going to add them together. So let's grab our calculators. And they're not going to come out pretty at all. So 170 times 1 over 38 is going to give me 4 point, we'll just say 47 since we're talking about dollars. Okay. And the second value, -5 times 37 over 38 is going to give me -4.87. So if I add those two values together, I get, oh, have to hit equals, I get -40 cents. So that's what I expect to win. I'm going to lose 40 cents. This is the expectation. Now, it's not really that you're going to lose 40 cents. You're losing $5 if you just play one time. This is talking about playing multiple times. Because when you play multiple times, there might be sometimes you win. You might win $175 at some point, but you're going to keep losing $5 up until that moment. And what ends up happening is you will lose more than you're going to win. And therefore, on average, if you kept playing this game over and over again, for instance, the question actually says, if you played the game 1,000 times, how much do you expect to lose? And the answer is you expect to lose 40 cents every time. So 1,000 times -40 comes out to -400. All right. So you expect to lose $400 if you keep playing. That means you've lost. I mean, you've won sometimes, but it means you lose more than you win. And that's on purpose. The casino sets up the values so that you are not going to get back what you started, because more likely you're going to keep playing. You're going to try again. You feel like, oh, I won once, I might want to win again. And I just have to wait long enough and eventually I'm going to win. And that's how gambling works. But the casino has set up their values so that that's not the case. Okay, I have another example, and I had to attach my keyboard to insert it. So hang on, let me paste it. Just throws it up very weird. Oh, it's the same example. Hold on, let me grab it. All right, here we go. Okay, it's really big. Let me size it down so I can write nicely. Cool. All right, so oops. Life insurance. This is another great example for expected value. Insurance in general is a great way of looking at expected value. So a term life insurance policy will pay a beneficiary a certain sum of money upon the death of the policyholder. These policies have premiums that must be paid annually. Suppose a life insurance company sells a $250,000 1-year term life insurance policy to a 49-year-old female for $530. According to the National Vital Statistics Report, the probability the female will survive the year is 0.99791. Let's compute the expected value to the insurance company. Okay. Yeah. All right. So here's the idea. Female is going to pay $530 to the insurance company. So the insurance company is going to receive $530, right? So they're asking us to figure this out according to how the insurance company is looking at this. All right. So they're going to get $530. That's their X. And that, or they're going to pay $250,000. Right? So they'll either get this or they'll pay this. Now, actually, they're going to get paid the $530. That's how you get the insurance policy. So technically, just like in the last one, I have to subtract out the fact that they are going to have taken $530 no matter what. So really, technically, they're going to do, or they're going to pay out $249,470. Okay. All right. Just being precise. All right. So what's the probability that they're just going to receive their money? Okay. That they're just going to get their $530. Well, that's going to happen 99,791 or 99.8% of the time. Okay. Like if I write that as a percent, I mean, there's literally like a 0.2% chance this person could die. 0.2, all right? It's less than 1%, less than 0.5%. 0.2. All right. So what's the chance that they're going to live? Well, we're going to take the 0.99791 and subtract that from 1. 791, plugging in my calculator, and I get 0.00209. Oh, I said chance that they'll live. I meant chance that they'll die. So that's precisely the chance that they would die. 2%, 0.2%, sorry, 0.2%. Technically 0.21 or 0.209, depending on how many decimals we want to throw in there. Okay, so here's what we're going to do. We're going to multiply these together and add. Okay, so I'm going to need my calculator for this. So 500 times 0.9791. That gives me 528.8923. All right. Negative 249,470 times 0.00209 comes out to negative 521.3923. And combining those together, in my calculator, I'm getting 7.5. So this is what they expect to get per policy. And I'm going to say profit because they're a company. So they're going to expect to get $7.50 per policy. And you're like, well, that's not that much. That's true, but they're paying out a lot if somebody dies. A lot. But because the odds of someone dying is so low, what if they sold 1,000 of this type of policy? 1,000 of these, just like the last problem. If they sell 1,000 of these, okay, they can expect to make 75,000, right? Did I do that right? Hold on. You move the 0, 1, 2, 3. Just kidding. 7,500. That's how they can expect to make on 1,000 of these policies. But think about it. They're taking in $530 per policy. $530 per policy. So this times 1,000 is actually $530,000. And if they have to spend $249,000 once that year, they're making like over the amount by a significant amount. So this is kind of taking into account that it's possible that more than one person could die, but it's also possible that only one person could die or nobody dies and they all live for the year and they get to keep all the money they brought in and put it into the next year. Okay. That's the idea of expected value. Now, I do want to point out that with expected value, I've only done examples where we had two problems, okay, two possibilities, but it is possible to have more than two possibilities. In fact, the activity you're going to do for this has an example where you use more than two possibilities, okay? You'll do their probabilities and then timesing the amount. And I believe there's 4 possibilities. So you'll end up doing that 4 times and then adding those 4 values together. And that's it.